Okay, this is going to be our factoring review, which is our section P5. We first start, anytime you have to factor something, you always look for greatest common factor first. So looking at this, we have -9, 24, and -12. So you pick the largest number that will go into all of them, which would be -3. You can pick 3, but because this first term is negative, you want to factor out a -3. Okay? Now, you have m to the 4th, m to the 7th, and m to the 5th. They all have 4 m's inside of them. So we are going to, let me move this down a little bit. Okay? We are going to factor out an m to the 4th. You take this lowest exponent. So 4, 7, and 5, they all have at least m to the 4th. Now we have n squared, n, and n to the 4th. You pick the smallest one, which is n. So that's what we're going to factor out of each one. Now, what are we left with when we factor out? When you factor out, what you're really doing is dividing this, okay? You want to ask yourself, what times -3 is going to give you 9, which is 3. M to the 4th, we don't need anything. We have an extra n here, n times n. Okay, so now when I multiply this times this, I'm going to get that. Now, minus 8 m to the 3rd, and n, I'm just subtracting my exponents, so I don't have that. Right here, I'm going to factor out a -3, which is going to give me a +4 m n to the 3rd. Now, some of you are wondering how I got this, okay? So, you can, what we're really doing to get this, what's left over in the parentheses, is we're dividing by our greatest common factor. Each term, we're going to divide by that. When you divide these out, okay, here's where you get 3. Subtract your exponent and you get 0, so you don't need any. You don't have any left over. And here you have 1n left over, so it's just 3n. Okay, so you can do this, these cancel, and subtract your exponents, and you're left with n, so you have 3n. Right here, 3 goes into 24, -8 times because it's negative. Subtract your exponents, and you get m to the 3rd. Subtract your exponents, and you get 0, so it's just n to the 0 power, which is 1. Right here, -12 divided by -3 gives me a +4. Subtract my exponents, 5 minus 4 gives us m to the 1st, and then subtract your exponents, remember this has a 1, and you get 4 minus 1 gives us n to the 3rd. You'll notice 3n, -8m cubed, plus 4m n to the 3rd. If I multiply this times, if I distribute this, I should end up with this. Otherwise, you've done something wrong. Okay, right here, you actually have 2 terms. Up here you had 3. 1, 2, 3. Terms are separated by plus and minus signs. So here you actually, this is one term, and this is the other term. Now this is a weird problem, and you'll never see this except for maybe one in your homework. Maybe. Okay? But anyway, what you want to ask yourself is, what do they both have in common? Well, they have 3 of these a plus 6's. This one has 2 of them. So they both have 2 of them in common, so you can factor out an a plus 6 squared. Now, what you are doing is you're actually dividing both of these by our common by our common factor. Sorry, I don't know where I was getting denominator from. Okay, so when that happens, I'm pulling 2 of these out. So I still have this 2a, but here this goes into this, and I still am left with 1 of the a plus 6's because 3 minus 2 gives us 1. So in this particular case, I have 2a times a plus 6. Right here, these cancel, so I'm left with just minus 7. Okay, so I've got to clean this up inside here. So I have a plus 6 squared times, I'm going to distribute this. 2a times a is 2a squared. 2a times 6 gives me 6, let's try 12a, and then minus 7. Okay, and then that's it, because this won't factor any further. Okay, the difference of two squares. If you don't know this, you better practice, okay? This is the easiest ones to factor. So they usually, we've given you a little bit more difficult one, but they usually start like this, x squared minus 25. This is a perfect square, this is a perfect square with a minus sign. It factors as x plus 5, x minus 5. Or you could put x minus 5, x plus 5. It doesn't really matter, okay? This has to be a minus sign, okay? Now, if it was x squared minus 121, it's going to be x plus 11, x minus 11, or I can put x minus 11, x plus 11, because they're both perfect squares. Okay, so in this case, this is a perfect square, and so is this. So, and important, there's a minus sign. So the square root of 25x squared is 5x and 5x. Okay, 16y would be 4y and 4y. One has to be plus, one has to be minus. These are conjugates. We talked about this when we were rationalizing the denominator. That's what makes that middle term disappear. Okay, if I used FOIL on this, I'd end up with here. 5x times 5x is 25x squared. This gives us negative 20xy. This gives me a positive 20xy, so they disappear. And then 4y times negative 4y is negative 16y. Be careful. This here, something that looks like this, does not factor. It is called prime because it does not factor. It has to have a minus sign. Okay, it has to. Okay, I still have something else over here. I was going to say there's a one that I like to put on a test, but this may end up to be one. Okay, first thing I want to do is, first of all, it's two terms with the minus sign. First thing I would look for is, are they perfect squares? But they're not. So really the first thing I'm supposed to look for is there a greatest common factor? Well, yes, there is. They both have an x and they both have a y cubed. So what I'm going to do is I'm going to factor out an xy cubed out of both. These are going to cancel. I'm left with x to the 4th minus 16. My x's will cancel, and so will my y's. Okay. Now, these directions only say to factor, but it's understood that it needs to say really factor completely. You have factored it, you just haven't factored completely, because this will factor further. It's the difference of two squares. Don't forget to bring this down. You have to have that, because when we multiply at the end, you have to end up with this here. And if you take this out, you won't. So this is going to factor as x squared plus 4 and x squared minus 4. Because again, that's the difference of two squares. These are conjugates. They look the same, but the signs are different. Now, if this is a test question, you would get most of your points, but you would get about 2 points off. And the reason is yes, you've factored it, but you haven't factored it completely because this is the difference of two squares. It's one of my favorite things to do on a test, is to give you especially something like this. I don't know about this part here, but I know I always put something like this on a test where you factor it and then you have to factor it again. Sometimes I'll have you factor out a 2, okay? But, okay, so this does not factor because it has a plus sign. This here, however, x plus 2, x minus 2, and again it can be x minus 2, x plus 2. This whole thing has to be your answer. Because if I multiply this all out, like if I multiplied here, I'd get this. Then this times this will give you this. Then this times this will give us that. Okay. I'm not huge on sum and difference of cubes. You will see it on your homework. In 1030, we just kind of introduce it, but here you kind of need to know it a little bit more. So anyway, the difference or sum, okay, this happens to be a difference because difference is subtraction. A sum is addition. Both of these will factor, unlike squares if it's a plus sign. Cubes it will if they're perfect cubes, okay? So these are the rules, and we think of the word SOAP. It only helps you with your sign, okay? SOAP. Same, opposite, always positive. Same, opposite, always positive. Same, opposite, always positive. That's what the SOAP stands for. Okay, now how do we do this problem? So here's what I would do. I would take the cube root of the first term, okay, which will be a. If I take the cube root of 125m cubed, now I don't usually do all this work, I'm just doing it to explain it. You end up with a equaling 5m. You do the same thing with b, okay? So the cube root of 27n cubed, again, I usually don't do this step, okay? So our b equals 3n. All right, so now that we know what a is and we know what b is, we can use our formula, okay? So because this is a minus sign, the first term is a minus b. It's the same sign. So you're going to get 5m minus 3n. Then you square your a, so that's going to give us 25m squared. Opposite of this sign, and you multiply these two to get 15m n. That's what a times b is, and then it's always positive. Square your last term and you get 9n squared. And the only difference was if this was a plus, this would be plus, minus, plus. All right, factor by grouping. Always when you have 4 terms, always. Group the first ones, group your second ones. Now what you're going to do is you're going to take this, hold on a second, let me get something to cover this up with. I'll use this post-it notes. Let's look at this. Take out your greatest common factor, which is going to be x squared. When I take out x squared, I am left with x plus 2. Okay, if I divide this by x squared, I have x. Divide that by x squared, I have 2. Now, I do the same thing here. I factor out my greatest common factor. Because this is negative, my first term is negative, I'm going to factor out a negative 9 instead of a positive 9. So when I factor out a negative 9, I am left with positive x positive 2 because I'm dividing it by negative 9. Now notice I did it in red. So now we have this. What do they both have in common? This is one term. This is our second term. We have two of them. They both have an x plus 2. So I'm going to pull that out. What do I have left? Okay, if I divide this by an x plus 2, that cancels and I'm left with x squared. Over here, I'm going to have minus 9. Okay, so it's x plus 2 times x squared minus 9. And again, it's because we're dividing both those terms by x plus 2. And they cancel. Okay? All right. The only thing we have to do yet is make sure it's factored completely. I can't factor x plus 2 any further. But this, again, one of my favorites, because I factored it and now I have to factor it again. Perfect square, difference of two squares, x plus 3, x minus 3. If you get to here, Pearson's going to count it wrong if that's what you put in. Even on a test, I will take off a couple points depending on how many points the problem's worth. Okay. And the last problem, I think, two problems. AC method. It is not one of my favorites, but everybody teaches it. Okay. I'll teach it, and there's a box method that if you had me last semester, I taught the box method. I think actually the last 2 semesters, so use that. Okay. But I'm going to teach AC method because that's the way most people will teach it in these courses, and not everybody had me last semester. Okay, so we're going to multiply a and c. So this is in the form of ax squared plus bx plus c. So my a is what's in front of my x squared, which is 2. So we're going to say 2 times my c, which is my constant, which is negative 5. And I get negative 10. Okay? So we want to determine two values which multiply to give us negative 10, but add to give us negative 9. So I do a little chart. Multiply negative 10, add to give us negative 9. Okay, so, and really these are called factors, okay, factors of negative 10. So we have negative 10 and a positive 1, or we have negative 5 and a positive 2. Yes, you could do 1 and negative 10. I'm sorry, you could do 10 and negative 1. But there's no way it's going to add up to negative 9. You need your larger number to be negative. This here gives us negative 9. Negative 10 plus 1 gives us negative 9. This is going to give us negative 3. Okay? So the two that we're going to use is this right here. Those two. So what we're going to do is we're going to take out this middle term and we're going to replace it with this of 10x and 1x. So I'm going to bring down my 2x squared. I'm going to take this out and I'm going to replace it with, minus 10x plus 1x, or just x. Now I could put x minus 10x. It will not matter. So what I did was I replaced this with these two. Minus 5. Now again, if you want to put a 1 here, that's perfectly fine. There's nothing wrong with it. Okay? I don't like the looks of that 1 though. So there you go. Okay, so now we have 4 terms. We just learned what we do when we have 4 terms. We group them. Okay, so I'm going to factor out a 2x right here. And I am left with x minus 5 here, this is positive, so I'm going to factor out a positive number, but they don't have anything in common. Every number has one number in common, which is 1. So we're going to factor out a 1. Doesn't do anything, but we're left with x minus 5. When you factor by grouping, if these two things don't match, you've done something wrong. So what do both these terms have in common? An x minus 5. What is left over? 2x plus 1. Guys, I cannot stress enough that you can't have enough practice in factoring. We will factor all semester long. Your next class you will factor. It's a really important concept. Now again, these can be switched. It doesn't have to be that way. Okay. Those of you that again had me last semester, I did what we called the box method, which I'll just show it real quick because it's pretty much kind of the same thing, except for we don't do this, the grouping part. What you do is you always put your first term in this upper left-hand corner box. The last term goes in the bottom right. Now, you still have to do AC and you have to do all this, okay? But what you do is you take these two values and you put your negative 10x here and you put your 1x right here, okay? Now, you factor by columns and by rows. So like right here, you say, what do they both have in common? They both have a 2x in common. In this row right here, they both have a 1 in common. In the column, they both have an x in common. I can't speak. And right here, because this top number, if these are negative, then you pull out a negative over here. If the top number is negative, then you factor out a negative 5. And that's what they both have in common, this here. Okay? So now, here's, you factored it. You have x minus 5 right here. And you have 2x plus 1 right here. So we didn't really, I taught this, but I always went to this because most of my students had an easier time with this. And see, like with me, I don't even factor using either. I just do trial and error. Okay, right here, again, I'm not going to do AC method, even though people will. I'll show you the box method. I just say x and x. It's the only way to get x squared. The way I'm going to get 35 is I can say 1 and 35. 2 won't go, 3 won't go, 4 won't go, but 5 and 7. And that's it, okay? Or it could be a negative 1 and negative 35, and a negative 5 and negative 7. Well, this middle term's negative, so it can't be those. And you can use FOIL, but I always say, okay, what multiplies to give us 35 adds to give us negative 12, and it's that minus 5 and minus 7. If I use FOIL, I'll end up with this. X squared, negative 7x, negative 5x give me negative 12x, and then negative 5 times negative 7 gives me 35. Guys, these here, I should have done this in, those numbers have to multiply to give 35. We don't deal with this at all in here until we say, okay, once I find the numbers that multiply here, then what adds to give here? Okay, we never pick this number to put these things here. Now, again, you can do box method. Okay, or AC method if you want. Okay, at box method, you put x squared here, you put 35 here. Whether it's AC method and you do what we did up there, but you still take A and you multiply it times C. So 1 times 35 is 35. You want what multiplies or factors of 35. Add to give us negative 12. And again, that's what I was doing right here anyway. I'm not going to do the positives because it's not going to give me a negative. So I'm going to say -1 and -35. That gives me -36. Or -5 and -7. That gives me -12. So I have to use these. That's the one that I want. So you put those, -5x or -7x, it doesn't matter, it'll work there, and -7x here. Now you factor out by rows or columns, either way, however you want to do it. I'm going to do rows first. They both have an x in common. God, I cannot talk. Here, they both have a -7. Because the first term's negative, you factor out a negative. Now you go to columns. Those were rows, by the way. I don't know why. Sorry, it's getting late. Right here, they both have an x in common. And right here, they both have a 5, but because this first one's negative, you want to factor a -5. This here is x minus 5. Here is x minus 7. Same thing that we got up here. So either way. Now, some of you may have trouble getting this right here, okay? Getting the factors. Last semester, I taught this in my class, but I don't know who had teachers that would teach it or not, so I'm just going to show it real quick. You're going to go to y equals, okay, and let's say you didn't know which ones added up. I know this one's easy, so it's okay, but we can still work with it. So you click your y equals button, which is right here, okay. Now you plug in the number, your a times c, and you divide it by your x, okay. Now your a was 2 times -5, okay, divided by x. I just don't like doing that. I like saying -10. That's just me, okay? But you can do it by plugging that in. Divided by your x. This button right here is your x button. We will use that a lot. I will teach from the calculator, so you need to get familiar with it if you don't know. Okay, once you have that, you hit your second button, which is rather blue or yellow depending on your calculator. And then you hit your graph, which turns the graph button into a table. Okay, so you hit second graph, which turns it into this table. And here are all your factors of -10. What you do is you go through and find out which add up to be -9. So we have 5 and -2, that gives me 3, so that won't work. 10 and -1 gives me a +9. So that means I gotta go this direction. That gives me -3. And this gives me my -9. So that's where I get my -10 and +1. So you don't have to do this table if you know how to use your calculator. And I think that's it for P5.